Um, so let's start with some of the concepts, and then we'll jump into iPhone apps, Xcode. We're not going to develop any iPhone apps today, but we will play on the playground. There's a playground provided from Xcode. So we're going to do some work at the playground, at least today. If we cannot do most of the work, then we could do one more week next week. But hopefully we can finish it, our play at the playground today only. Therefore, we can do our development job. So before we get to that point, let's take a look at some of the concepts, some of the technologies. So we're going to review something, okay? So it's not a tech-intensive lecture, the first half of the lecture today, but second half, then we'll go back to Xcode. So that is the codings. So a little bit of so knowing and gaining the skill sets and understanding of a few other programming languages, then we need to adjust a little bit to an high advanced programming language of Swift, purely object-oriented language, of course, because iPhone apps is completely graphical user interface. So we'll do that. So without understanding object orientation completely well, that is not really, you can still follow this lecture because I give you we can do all the codes together, except your project. Your project that you should do on your own, but the class, all the language details and skills that we will cover in class. And from this time, most of the work that I ask you to do for your homework assignments is redo the same thing that we cover in class, and I ask you to submit. Okay, so I want to make sure that you are following all the codes that we cover in class. So while doing so, that is your practice. That is the learning of your gaining the coding skills in Swift. So with that skill set, I hope you can you can complete your project. So project proposal will be requested sooner. So I want you to think what you want to implement for your iPhone apps. Don't try to change the entire world by completing this class project, okay? But with that ambition, I want you to start from this class. And the completion of your project may be years later, then you will be a billionaire. Don't forget me at that time. All right. So what is a mobile device? Mobile device is a computing device, small enough to hold and operate in the hand. So that's a handheld device usually. Mobile, so that is a movable, right? Moving objects. Anything that any such device, you can say that is a mobile device. Raspberry Pi, of course, that is a mobile device. And all other commercial products, if you carry your cell phones, that is a mobile device. If you have Apple Watch, of course, many things available. So types of a mobile device start from smartphones, tablets, laptop computers, smartwatch, e-reader, electronic readers, handheld gaming console. Anybody here playing game on some small devices? Not quite. You do? Do you have that with you right now?
No, I don't know if you heard about the Steam Deck.
Oh yeah. How do you how do you like it compared with, for example, iPhone device?
I could play my PC library on the Steam Deck, like the iPhone.
I mean, gaming itself.
Yeah. I also I could use it since it's Linux based. I could go into Linux.
Okay.
It's around in the desktop.
Okay.
So, yeah, I like it on the phone.
So, phone device is maybe the handy and also powerful gaming console, right? But maybe 20 or 30 years ago, yeah, when my son was in high school or even younger, he had that handheld small devices, right? Play all the time there. So, so it was simple for me to control. I can take it from his hand, then he can study or he can do something else. But now, smartphones, right? So smartphone can do almost all the entertainment tools available. Wearable computers. It depends on the definition of a wearable, but maybe smartwatch, that's part of a wearable, but there may be more than that, right? Wearable computers really useful for medical purpose, right? Yeah.
The Apple Vision Pro.
Oh yeah, Apple Vision Pro. Yeah. Do you have that?
No,
That is expensive, right? But not quite useful yet.
not quite used.
Yeah. Not many medias, not many contents available, or should go through that that device, right? Yeah. One of the wearable, it's not really a human wearable, but uh, probably we looked at that one of the TV sets announced in CES Las Vegas in January. It looks like a window, transparent, right? But we can turn it on, then it'll be a TV set. So if we want to TV sets, it is TV sets. Other than that, it may be a picture frame or maybe Windows frame. Yeah, it's not really human wearable, but technology is there. Digital cameras, smart cards. So we'll look at principles of mobile app developments. It should be user-centric design. From this, many slides discussing about the principles. I'm not going to explain all. Maybe I may take one bullet points, 3 hours or 4 hours. I can spend this whole thing for one semester or a year, but that's not our desire, right? So let's look at quick. If we understand, then we go. Okay, we move on. So user-centric design, that is, yeah, no question about it. Performance optimizations, of course, even if any computing is performing on our smartphones, the size is small, therefore it performs slowly, then it's not acceptable, right? Performance optimization is really one of the important principles. The other one is platform compatibilities. While I am working on my laptop, I continue to work on my mobile phones. Therefore, I can play on the same page all the time, right? While I am working at work and on my commute back home, if I want, I can still go back to the work that I stopped at work, and I continue to think. And when I get back home, then I can open it up again. So platform compatibility, that is also very important principles. Of course, the security, right? No question. Scalability. Some job, if it is small, it works well. If it becomes bigger, it slowly works and then finally stops, then it is not acceptable, right? Scalability usually is not unlimited, right? There is always a limit, but reasonably scalable. That is the scalability that we are thinking of. Offline functionalities, even if we do not have the connections, I hope it should work, right? It depends on the functionalities. Some functionalities definitely need always based on connections, but if similar functionalities goes well with no continuous connections, then it'll be also good. Another way is, for example, you want to access some databases in cloud server. And you may expect it to go somewhere where there is no connections. Even if that case, because smartphones, cell phones usually have the database by default. It's not really the full functionalities of database technologies, but anyway, the minimum we can save something, and small SQL statements maybe works on your cell phones. Therefore, if your mobile applications bring down a good amount of data to your local iPhones or smartphone databases, then you can still continue to work, right? That type of things, offline functionalities. Regular upload and maintenance. This is a real big issue. Within parentheses, I put there SSC, CI/CD. What does that mean? Anybody knows that acronyms? SSC stands for software supply chain. Software supply chain. CI/CD, continuous integration and continuous deployments. That is really needed for particularly smartphone applications. The best developer is to update your applications continually and maintain your application current. Recent days, I have Tesla app. I have a Tesla car. Tesla usually well-known software, advanced software companies, right? So we can control the car from the app. So I downloaded the app when I purchased it about 2 years ago. I never re-downloaded it manually. Hope they do that automatically while I sleep or whatever, right? But apparently they didn't do that. So one time I thought there is some issue on my car. The issue was GPS data was not correct. It's never updated. There is a location on Tesla app. There is a location buttons. If you click the location button, for example, if my wife is driving, then that shows all the maps and where that car is currently running. It stops somewhere and then never moved for about a month. So I turned off my phones and back on. Didn't work. So I tried to get some services. I made an appointment, and one day I realized, what if I re-downloaded the app itself? So I re-downloaded the app itself. So it worked, right? The problem is only on that app problem. It's not hardware, it's not mobile, it's not Tesla cars issue. Only that is an app issue. App was not continuously deployed. Okay, it's not good, right? So one of the principles that I realized also the significance is regular updates and maintenance. Should we do that? Should customers do that manually, or vendor could do if we agree? That type of services is not really the issues of securities, right? I really trust them to updates my app. Anyway, while I am keeping that car, I need the app, right? Under that agreement, then that should be solved, right? So deployment is important. And feedback and iterations. So developers should actively solicit feedback from users and stakeholders and use it to iterate and improve the app over time. This type of things that they need, right? If they develop an app, I don't see any app scrolling all the way to the bottom and there is a help feedback buttons. So if you have any issues, please write something on here. Have you seen that kind of app? I haven't seen, right? Particularly back to that Tesla cases. Tesla is a vendor, right? Only the reason that I am using Tesla app is because I am operating Tesla car. Then I am their good customer. You know why we do that? It's because this classroom's monitor is not functioning right now. So we all connect. Okay. Simplicities. This is also a good feature, right? I have an echo here. Why? Okay. Yeah, some apps designed and it's very hard to locate some functionality that I know there is a functionality. I know I once used it, but later if I want to get to the exact same functionalities, then I should have hard time. I should scan through all the menus everywhere, and it takes me maybe an hour or longer to get to that point. That's simple points, right? It's not a good idea. So simplicity is really, really one of the handy points, right? When you develop iPhone apps, any kind of smartphone apps, then make it simple so that the customers can get the services, right services, anytime, anywhere, quickly, right? The other better idea is if you can customize the menus while you are downloading some apps. I don't see any apps doing that, right? Apps, once you download it, then predefined, and we need to accustomed to the way they designed, right? Although even if I do not use most of the menus, I need to use only one small menu which is located deep inside. Then that's not good, right? So I don't see this powerful apps yet, but if there is any capabilities that you can redesign the menus a little bit, like a drag and drop, and I want to pull this menu up front, and the other menus that I rarely use, then I push it deep inside so that I don't see that menu from the beginning, that type of things. Okay, think about that. So that is, if you do that, then that's powerful, right? Testing and quality assurance. Of course, it's not this principle is not only the case for mobile app developments. Anything, even civil engineering, constructions, testing and quality assurance works, right? And compliance with the guidelines. Yeah, compliance is new rules. Depending upon the target of your smartphone apps, there may be very, very strict guidelines and compliance issues. If you need to develop banking apps, then banking systems always apply strong the compliance regulatories from SECs, yeah, federal issues, all international issues also, because that's a monetary sensitive issues. So when you develop app, you have to also consider that. In this case, CI/CD is also very, very important. Continuous integration and continuous deployments. Compliance rules may change it, may update frequently without sometimes notice you guys, right? So you have to keep listening to their legislation, and if that is the case, then you have to change your apps. That's particularly the case if you want to develop the app to transfer money from one person to another person. There are quite a few apps available, right? Money transfer. Analytics and monitorings, that's for your future investment, right? Once you launch out, once you deploy your mobile apps, then you need to gather the data to analyze it and keep monitoring, see if any issues anywhere. If you do this, then what? Inside your app, you have to. There's some issues, right? Some security issues. There, you want to control something continually. Monitoring is kind of control, right? Gathering some data from clients, knowingly, unknowingly. Customer may not know. Keep communicating with external IPs. So usually, for cybersecurity professionals, they can set up access points, router, software router on the Raspberry Pi, for example. I used to teach that, but not anymore. I still do that. When I buy some mobile devices, then I first connect it to my router, where I installed all the packet inspection programs, so that I look at who is talking to this device. I continue to monitor maybe a couple of days. If there is no suspicious IPs found, then I can continue to use. Other than that, I need to make sure. Well, this guy is communicating with my enemies. It may be possible, right? I tested many times when I first to install the Zoom like this time, right? So I want to see where this Zoom is communicating. Zoom communicates so often, so many different IPs. For example, my lecture, do you think only one IP is communicating with my Zooms? About tens of different IPs. Sometimes go to Virginia, sometimes go to California, sometimes always. So I collect all the IPs and find out what this IP is, right? So make sure that IP is the trusted. That IP is for the device that I think I can trust, right? It's not really secure, even if I verify it. What if from that device to relate to some areas, right? It is also possible. iPhone App Store, if we want to sell ours, then App Store usually verifies how many points that this guy wants to communicate with others, right?
How many more?
How many points that this guy wants to communicate. For example, how many IPs outside. For Android, open, right? So if you want to attack, you may use Android phone application developments for cybersecurity purposes. iPhones, I also develop quite a few iPhone apps and also communicating with the external IPs that we are going to learn also. One of the IPs that we set up in our department. That IP still works, but I am worrying about if the system may die. No one's maintaining right now because that is going to terminate sooner. So most of my work, I moved to cloud server, my own cloud server, but I didn't move this class to my own cloud server. Because this is a class, right? It's not my own work. So it's still in, you guys connected to the department server. And also the server names, everything is owned by me, not by the department. That's my contribution. Okay, so analytics and monitoring, that is also one of the important principles. I think this, yeah. So 12 principles. Let's read once more. So user-centric design, performance optimization, platform compatibility. Those are all important principles, right? Security, scalability, offline functionalities, regular updates and maintenances. As I noted, software supply chain, continuous integration and continuous deployments, feedback and iterations, simplicities, testing and quality assurance, compliance with guidelines, analytics and monitorings. So with that principles, I want you to think now, which one that you want to use, iPhone or Android apps, right? But this class, we do iPhone apps only, right? I've taught Android apps developments 10 years ago, but since I think 6 or 7 years ago, the Mercer universities, we teach iPhone apps developments. Still, many other universities teaches only Android apps developments. All the other countries, Android apps is open to everywhere, right? We can use it. Only the issue that I want to develop iPhone apps, at least in America, iPhone is dominant, right? Dominant. Dominant. Yeah. Yeah, that is the reason. There is no other reason. But we can take a look at here. It's a difference between iPhone apps and Android apps. With the skills that you learned in this class, if you want to develop something for iPhone devices, then you need to take a consideration of these issues. First of all, programming languages. iPhone apps, usually it was started from the Objective-C, and now Swift. Swift is much easier than Objective-C. Swift is very similar to Python or Java, right? Android start with Java. So I am the earlier generations of Android apps developments. So I used Java, but nowadays they use Kotlin, right? Kotlin is a lot simpler than Java language to develop Android apps. So you may think of that if you want to use it. Development employments. Development environment. Xcode for iOS. Android has also IDE, integrated development environment, which is Android Studio. So, but we are going to use Xcode here. Xcode is also powerful. User interface design. iOS also good, powerful user interface. We will use, there are two modes available for iPhone apps developments. Drag and drop the graphical components and design the layouts that will be your iPhone apps, which is easier. That we're going to play with. The other way is to use Swift UI. All the graphical user interface should be coded. So it's not drag and drop. It's not something that you can see immediately. Well, Xcode gives you immediate emulations, but you have to do everything that you want to do, then you have to code. So we don't do it in this class, at least. So we will stick to UIKit mode, easier. Android has a similar things, drag and drops. All the graphical user interface saved in XML, the Android case, which is handy when I used to develop Android apps. Then everything can be, once you design, drag and drop the graphical components, so you may have good layouts. Everything is in XML. So either you can change XML code or you can read drag and drops. Correlated, which is But that's not the case in iPhone apps. It's not Xcode. In that way, I think Android platform may be better. Fragmentations. How much that we can make it fragmentations? If you have a finer granular fragmentation, then you can do so many small pieces of your apps or big chunk of fragmentations. All depends. So let's read here. Apple has a relatively small number of device models compared to Android, resulting in less fragmentation. This makes it easier for iOS developers to design and test their apps across different device and screen size. Android ecosystem is highly fragmented with a wide range of device manufacturers, screen size, resolutions, and versions of the operating systems in use. Developers need to account for this fragmentation by testing their apps on various devices and OS versions to ensure compatibility. Apps distributions. iOS, iPhone apps through Apple App Store, Android may vary, right? So many different places like Google Play Store. Yeah. Market share and monetization. iOS is smaller market share. Android is bigger. Okay. Now, unfortunately, we are going to, it's not from your preference, but I chose iPhone apps developed on Xcode using Swift. That's it. So Swift on Xcode. Variables are always initialized before use. That is sometimes a little bit of a headache. Because you do not know the data, but you have to initialize it. You do not know what data can be transferred from outside, but still you have to make it initialize. Array indices are checked for out of bounds error. That's always, not only Swift. Integers are checked for overflow. Yeah, all other languages. Optional ensures that nil values handles explicitly. In Swift, there are optional value or explicit values. Two different things. So optional, then there's a suffix question mark. If it is explicit value, absolute value is expected, then exclamation mark. So either question mark or explanations. That's Xcode kindly suggests to you to choose either question or exclamation mark. You can decide, hey, this is optional or mandatory. Therefore, the code below that statements definitely need a value. Then you need to put exclamation mark. Therefore, you will not get any exceptions, any errors. Your code makes sure data comes in. It doesn't make any further move on. Memory is managed automatically. That is a good things. Garbage can be collected quickly. Error, and there is another the menu, drill down menu that I can tell you. You can clean up if you think, oh, there's some issues. Then you can explicitly click that button. Then all the errors cleaned. You start from a clean space. Error handles allows controlled recovery from unexpected failures. Powerful type inference and pattern matching with a modern and lightweight syntax. Yes. I'm expecting sooner or later we may have different the coding environment when it comes to machine learning components are included. Right now, Apple doesn't include any devices machine learning components, but maybe year later, at earliest, but sooner. Then my lecture should be changed also. I am already headache to catch up all those things, right? So many things. Apple wants to develop autonomous vehicles, but they decided not to, right?
Like
They gave up.
absolutely.
They gave up. So Tesla is only the company now pursuing fully self-driving packages. Have you guys tried the fully self-driving packages? Probably not if you do not have. I purchased it when I purchased my Tesla because I have my retina. My retina was detached about 20 months ago, so I had a big surgery. So my vision is not clear. Even if I looking at you guys, but my vision is not the way that you see me. You may see me a lot clearer than the other way. I don't see you guys clearly. So, autonomous driving is, I thought, useful to me. So from time to time, I use it. It's not like I don't feel comfort at all when I turn on auto. It's more than autopilots. I feel scary if I rely on. It's not 100%. In other words, okay. So somehow I need to get used to that software. Should I? I don't think so. So I don't, right? I do not wait till my car behaves the right. Usually when the car encounters some other obstacles, some other cars surrounding, decision making is a lot slower than myself. Sometimes cars like turning right, left, right, left, right very quickly. So it's trembling, it's shaky. The car is definitely shaky. Then I need to hold my handles and intervention is needed. But anyway. All right, so Xcode needs to be downloaded. I think you guys have Xcode, okay? So move on. So Xcode Playground. So we'll do Playground. From this, let me go through this quick and then we can do. If you do, this is UIKit. This is old ones, okay? UIKit is just like this. UIKit based playground is still available. So we can get to this also. You have here left side, left pane, this is organization of your files. This is file system. In the middle, there's editor. On the right, then you can see some of the utilities, some of the libraries. You can use entire for your editor. You can also minimize the left side. And the bottom here, that is the outcome of this, your code. This is a Swift UI. Swift UI has emulator. And this is your code. This is the utility views. And also your file systems. Emulator may be activated like this. From your Swift UI is by default. You can also go to your UIKit playground. Here, file, new, and there's a playground, and it goes to UIKit playground. Okay, this is important from this slide. How to play on Swift UI playground. Use a struct block of view to play codes in the body. So there's a content view, which is in struct. Struct is, anybody here knows C programming languages? You tried? Anybody tried to see? If you guys try to see, then you can see the struct. Struct is kind of a block of code. Design some of the components. The current terminologies that you can compare with the struct now is very similar to the class. If you know Java or Python, the class is very similar to struct in C. So Swift allows class and Swift both. You can define, for example, some complex data types, then you can use struct. If you think, oh, this is a real object orientation, then you can define class. And you can say there are two things, right? If it is object, if there is a class in object orientation, then two things basically needed there, right? Structural components, structural aspects of data, and behavioral aspects of data. Behavioral is nothing but the function definitions. Okay, so class has function definitions, and also behavioral definitions, which is the fields, all kinds of the variables can be declared and initialized within class definition. That is a class. Similarly, a lot simpler than class definition is a struct. So in this case, struct and content view. Content view is given struct. This is not things that you need to modify or change. Content view is given. What is the type of a content view? Content view is view type. So you have a struct, content view, colon, followed by type. So content view is in the type of a view. If it is the case, then all things needs to be followed, right? View itself. So, and then inside there's a body. There's a components of that struct. And it says some view. View is the type of some view. Go back to the bullet points. Some view means that the body will always be implementing the view protocol, but the concrete implementation type does not need to be known by the caller. So detailed implementation is up to you. We don't really ask you to follow the view strictly. If it's the case, then we may say the view. Reason we say some view is I want you to work on. Okay, your view implementation is my view. Okay, we will allow you to do some view of your implementation. So look at this here, variable body, colon, some view, in an open curly brace, and there's ending curly brace. So inside here, that is your implementation. Okay, please do not change any others. So there's some comparison between struct and class. Common. It defines the properties to store values, methods to provide the functionalities. Properties that I was talking about, field variables. Method, I talked about behavioral aspects, like function definitions. Method is nothing but functions. In this case, define subscript to provide access to their value using subscript syntax. Define initializer to set up their initial states. Be extended to expand their functionality beyond a default implementation. Like some view, then that is beyond some default implementations. Conform to protocol to provide standard functionalities. Here, class with more capabilities than struct. Very similar, but class, more capabilities. Here is it. Inheritance is possible. So somewhere in, not in these samples, but you can say super dot something, then it means you want to implement, you want to inherit. Typecasting enables you to check and interpret. Typecast, for example, class, once you define class, it is nothing but a type. Struct, that is also nothing but a type in object orientation. You guys learned object orientation, right? 505. So depending upon that class hierarchies, you can cast the types. Let's say student is a subclass of person. Then you define the class person, class student. Student, therefore, a type of a person. Once it is a student, you can say that that is also a person. Not all person can become a student, but all students can become a person, right? That's a typecasting. Although it is a student, you can cast it to person. Deinitialize is possible. Reference count is possible, but we don't really do. Okay, here. This is a, so in the previous slide we looked at the struct content view, colon view, open curly brace, var variable, body colon sum view, open curly brace. This is your implementation inside. In this implementation, you said vertical stack. Look at the bullet points. Write on your phone view using text. So we'll look at the text only here. Text. Text means you want to display something, like print. Okay. If you do print, then you can print. Let me go back. Yeah, if you do print, then it can print here on your. This is editor, the bottom of that editor. Then you can see on your code. If you say print something, then it appears here. If you want to print something on your device, on your iPhone, print statements is not going to work. You have to use some graphical components to display. One of the graphical components, simple ones that we can play on the playground, that is text. So using text, then you can display something. So we use display, image, it's a vertical stack, horizontal stack, navigation stack. Stack means not only one time of writing, but you want to stack. When you write something, or you want to write that vertically. Vertically means you write one line. If it is horizontally, then another text follows horizontally. That is horizontals. Vertically, you make one line, and next text, vertically next line. That's a V stack. And next line. Then that is a vertical. Continually appended line after line after line, then on the same line, that is horizontals. If you see your smartphones, some apps you can continually horizontally look at, right? So long line of components available. Some other times you can do vertically. You can scroll up, down. That capability is also practiced on this playground. We'll practice this. Let level 2 equals 3. Let level 3 is 4. Let and var. We have two declarations of variables. If you say var, then that is really variable. If we say let, then what do you think it is? Other than variable, it can be constant. Yeah. If you say let, followed by some name, then this is a constant. What is a constant? What is a variable? If it is constant, then will not change, right? Only one time, under that name, one value. Variables, then you can keep changing. Okay. Plus sign, then you can concatenate string by string. This is very, very important. Function definition and function calls, which is not in many other languages. How do you usually define function? For example, in Python's def, followed by function name, open parentheses, and list of attributes, right? Because Python is not typed language, you don't need to explicitly define type of each variables, right? But Swift is a typed language, so you need to say variable colon type, right? If it is a string, you need to say string. If it is integer, then int. Floating, float. Double, double. Whatever that way, right? Look at this. So we have here underscore. Back again. This is Swift start with the func rather than def. Okay, so you need to change your mindset. It's not anymore def, but func. It's a good name, right? Func. Right, Jessica? Func is better than def. Def? Func? Okay, func followed by your function name. Open parenthesis. Two names after colons and type, comma, two of the names, colon, string. I mean, the type. You continue to do that. And finally, close parenthesis. If this function needs to return, then dash and greater than sign together, like an arrow, followed by type of a returning value. So you want to return the value in string. After that, implementation bodies. So open curly brace and close curly brace. Inside that is your implementation. Here in this example, simple. Return howdy, the name. Okay. So as I indicated here, this is language is a function name. The first, inside the parenthesis, the first three names with the one colon ending with the comma, three names. But first name is simply underscore. Second name is apparently here is called the name, colon, string. So these two variables, these two parameters in string, I think we can understand that way, right? Comma. Next one is more clearly. Compile, execute, colon, string. So there are two variables pointing to the same things. Typical programming languages, like in C or Java, those are typed language. Then one name, there's a variable name, colon, type of that variable, right? So in this case, two names. Okay, so if you look at that, then it looks a little bit messy, right? Okay, the first one, a little bit gray ones. Gray ones points to the second value, right? Gray ones. Because the first one is underscore. It looks like didn't mention explicitly, right? But it indicates, oh, this is the location of the first value, first name. And second parameter name is called the name here. And I said that there is a parameter name. And this parameter name is the variable that are used in the implementation. This name is handled within that implementation body. Look at the next ones. Compile, execute, compile, exec, colon, string. So compile is the first parameter, right? I call that argument label. Second one is internal. This is implementation language, local language. EXEC is a local language. Compile is argument label. What that means is that, I said here, that is the variables that are used in function call. This compile is not the variable that you can use here in this body, but when you call this function, language, see your print, language, the first parameter didn't say anything. So you simply send the value, Swift, comma, and the next one. Next one, if you see that, then this is the variable for caller function. This is a variable for called function. So you have to indicate this, compile. You have to use this variable here, compile, colon, followed by name. Then this playground goes to exec. This will be bound to when it is called, then exec variable holds this value, playground. All right? Right now confused, right? So we'll practice this. This will be a little bit of the homework assignments, next homework assignments. Okay. So what we will do? We will practice, first of all, this. I want you to start with Xcode. On your MacBook, there's Xcode. Let's start with it together. So you have Xcode. Click on Create New Project.
We do it now.
Yeah, do it now.
Okay.
You guys see Zoom right now, right? So click on that Create New Project. And if you see here, on top menus, multi-platform, iOS, Mac OS, Watch OS, TV OS, Driver Kit, and others. We're going to work on iOS. I'm going to just showing to you, right? You don't need to click anything yet. And then the actions for iOS, there are app, document type, game, augmented reality, AR application, augmented realities. This,
Can you go and take your Mac download the Xcode because I don't have it?
yeah, please download it because we cannot. So when you're ready, you can follow this recording.
The Xcode developer tool is the one that we have to download?
There's on slide, right? I guided you.
Okay, so choose tablet app, document app, game. So I'm choosing the app, right?
No, not yet. Yeah, I'm guiding you. App Playground, Sticker Pack app, iMessages, Safari extension app, and framework, static library, metal library. You can scroll it down. Then audited unit extension app. So many things that we may need to do. But today, and in this class, throughout this class, today particularly, we'll look at this app Playground. But when we develop iPhone apps, maybe from next week or after, we go with this app. So we usually go with the app, but today, because we need to practice a little bit of Swift, so I want you to play on Playground first, get some understanding, then we come back to app. So click on that app Playground and next. Now we need to put here app name. So my suggestion is, because this is not your regular app applications, right? So start with the PG, Playground. So this is not your app. So PG and then my first Swift. You name it, okay? And then team, you can, as you develop yours, as you install this Xcode, you probably have yours, right? An organization identifier, usually your name, .com. So com.jongyun. Bundle identifier, if you didn't purchase developer ID, don't worry about this. You simply use your temporary users. If you want to, you can purchase. The benefit from the web developer ID is that you can deploy your app on your cell phone device anytime without having to register at the Apple App Store. I haven't, yeah, you guys need to, yeah. Okay, so you name it, and next. And this, here, you need to decide where you want to save yours. So I have iOS app folder, iOS app, you can define. You can create app, the folder, if you want,
Can you go,
or you can save it anywhere.
can you go back a little bit? For the storage, you were doing the Swift data or core data?
We don't use any coded data.
Just Swift data.
Did we have that?
On mine it shows storage. Now
Did you take
core data.
app or Playground? You probably use app.
Yeah, yes.
Don't do that. Too early. Core data is a database. So sometime later we are going to use that, but not for a while. App, not today. Playground only.
So organization identify use any name.
Yeah. And then we can click on create. So don't worry about this, but this is on top of this PGMY1 Swift. That is the name that I made, right? If you click this, then all can be hidden. Click, then you can see the content of that project folder. I want you to click one of those. The first one is content view. Then you can see this, the code. Your editor can be divided into two parts. Left, the code itself. Right hand side, emulator. If you see the emulator, then bottom somewhere there, my cursor is moving there. You can choose the type of the model of your iPhone. You can choose anything. You can choose a tablet, for example. Maybe yours by default shows tablets, but you can do more. iPhone, some model, 15 plus, or iPad, whatever that you want to do. But this doesn't. Even if you choose something else, it doesn't affect you any at all. This is only for you to visualize. Left hand side, that is a code that is visualized like this. If you see the code carefully, this is something that we looked at. Struct content view, and next line, there is a sum view, and even further, there is a v stack, highlighted 3 lines, so you guys can understand. There's a virtual stack. So whatever I can say, these two, this is one line, image, another line, text. So image and text are vertically stacked. If you see that emulator, there is an image, small images. You can maximize it. I cannot move this. Okay. Yeah. So there's a globe, image, logo. And then next line, hello world. So you can feel somehow from this given code, we didn't do anything. This is by default given. This playground gave us this. So images appears here, and text, hello world, that's written there. If we want to change here, hello John Yoon, you have that, right? If we want to more, then you can see that. So clearly we know, oh, this is a vertical stack, right? So we have 3 graphical types: text, 2 text, and 1 images.
How can we move that like to the top right, top left? You see how
Not here. Yeah. There's a code. We can do that on app.
Yeah.
Yeah. You can do that if you do the Swift UI, because this is a Swift UI. Remember here, Swift UI. Swift UI. In Swift UI, you can manipulate so much things in coding, not drag and drop things. I'm not sure you guys are ready. So sometimes I do, because of this, I continue to give a lecture, and then I ask you guys to review. Yeah, some students go fast, some students need more time. We have a limited class. class hours to make it maximize. So because I'm recording anyway, so otherwise I'm idling. My idling is recording. Okay, how many of you are now ready? I mean, at the same page as I am. I think Eduardo, you are with me. Jessica, are you? Okay. Others?
I have a cosine arrow.
So yeah, you have to make sure. Yeah. All that details I cannot help you. That is between you and Xcode. So you need to take time. If you are not lucky, you cannot do it quick. That's what I had. It takes time. So you do that at home while you have spare times. Figure out how you can make it work. You should work. It's not impossible, but sometimes it takes time. So I wanted to look at here then image. If you do image, then system name globe. This is given, right? This system has some images available. We call it globe, but maybe something else. This is the ending of that image, right? Image, open parenthesis and close parenthesis. After that, we have a dot. This is very handy, right? Dot followed by some of the functions. When you do these images, then it creates an object. If you consider object orientation, then this is an object constructor. Then this is nothing but objects. That object, dot, and method name. Object that you are using here is an image scale. I want to make it large. And then another dot. This is something different from Java, right? This object can have dot method and another dot and another method. You can continue to make it if those all methods are applicable for this object. So image scale. Next one is foreground color. If it allows, for example, I'm not sure if it allows background, maybe background, and let's say color, maybe, I'm not sure. Let's try with the here background and simply blue. Oh, it works, right? See here, blue. Purple. Yeah. Orange. This is handy, right? So you can call the method in one line, on the same line. And this text also you can do, if you put here dot, then you can see some of the methods that you want to. Let's say font weight, bold. I'm going to use this as is, bold. Say bold. So do you see the difference? Hello, John Yoon is regular, but at Mercer University there is a bold face. And you can also do foreground color, foreground style, foreground color. Here, foreground color, foreground color. There are color red, orange, white, gray, accent color, black, blue, all the choices possible: brown, cyan, indigo, mint. What is mint? That is mint. Oh, this color is called mint. Okay, back to the slide. Okay, we'll do let and var and write it on text. Okay, so we will declare. Usually that declaration on better to have on top. So var, we can say class called string, and then we mobile tag. Let teacher string John Yoon. Oh, because this class is there's a name class. Class is a reserved word, so we can say course. Remember that when you define the class in object orientation, then we use a class. There is some warning. Variable course was never used. Consider the replace it with the underscore or remove it. We will use it. Don't worry. This guy is. Be patient. So we can do text. In text, we can say, I want to say, this teacher teaches this course. How can we say it? Here. Who teaches what? One way that you could do is, this is not really Swift way, maybe Python way. You could do it in this way. Teacher teaches class. Then you can see John Yoon teaches mobile tech. So I want to put there some white space. Then you can see John Yoon teaches mobile tech. This is not really Swift way. What is a Swift way? Swift way is this. You can do backslash, open parenthesis, and teacher, and teaches, another backslash. Can you see the difference? Those two?
It's like in Python when you use f.
Yeah, there's a placeholder. Yeah, like one string that can hold the multiple variables with the the placeholders. Similar to that, here, yeah, we have backslash. Usually, what is backslash in coding? Backslash is usually called escape character, right? What that means is that if it is a quote, then your compiler, as it scans, when it encounters a quote, then it tries to copy without evaluation, right? But if we have a backslash here, then escape from that quotation. If it escapes from quotation, it means, hey, I want to evaluate it. So what should I evaluate? I evaluate whatever within that parenthesis. So teacher is not string teacher, but teacher should be evaluated. And this guy says, is there any variable called teacher? So up there is a teacher. So bring that down. That is what we do, backslash.
How you do comments in Swift? Is it the same?
Forward double.
For
Yeah. To double forward slash. If you have a block of comments, then forward slash star. That's the beginning.
Yeah.
Ending with a star with the one forward slash.
So
One forward.
like C.
One slash one star. Yeah, like C.
got a question.
Yeah.
It says cosine wants to access key, Apple development, my name something. So is it my computer password or the Apple password?
Cosine?
Cosine, one word. Wants to access key, Apple development, my name,
Um,
my ID.
Use one of those, and if it doesn't work, then use the other. I had that similar issues at the very first time, but I forgot how I did. I had that one time failure and another time succeeded. Yeah, cosine. What about other guys?
There's no word.
Was it your device password or your membership password?
No. I didn't have Xcode on my laptop.
Oh, you didn't have it yet.
Yes.
I thought you were flying. You were following me because you were.
But I do it when we get the video. So.
Oh yeah. Okay, so we'll do function. Okay, now. Oh, let me explain. This is first variable, content view. What about next variable? My app. Look at that. Import Swift. Main struct my app colon app. Variable body colon some scene. And then window group. And then there is a content view. This content view is some familiar with, right? What is this content view? This content view is the other file that we already played with. So these two files collaborate to emulate yours. Okay? So don't remove this my app. So my app holds this content view to emulate yours. Okay. Here's a B stack, and I want to define a function here. Func. What did I do? We have a function definition somewhere here, right? So we're going to use this similarly to this, but not exact ones. So we need to practice some. So func, I would say tax calculation. So we give taxable income. Taxable income is a variable, but that is a color variable. And then we can do internally income, and then that is double. And tax rate, and we call that rate. Two variables, two names for one variable with the colon and type, float, and it returns double. And then we can do manipulations of that. What we will do is we return float, not flog. What is this? Float, FLOUT. FL08, float. So we need to calculate the tax, right? We simply do return income times rate. That is returned. Oops, what is this? Double and rate. So we can do, there's a suggestion, replace the rate with the doubles because double is a bigger size. So this is a function definitions. There is a taxable income, that amount needs to be multiplied by the rate. Then it gives us tax. Similar things I want to display on here. So we can say tax. We need to call my tax, and then I need to call that function, right? So backslash, and then function is tax calc. So when I do that, it gives me tax calc, taxable income. Hold on. Let's practice in this way. Let's call that first, okay? So we can say variable my tax, that variable can contain the returning value from the function called tax calc. So this guy recognized this definition of functions quickly, right? Tax calc. And this guy says two variables, taxable income and tax rate, right? That's given. I want you to look at this taxable income. That is the first name of the first parameter. And then tax rate, that is also first name of that the second variables. It automatically take what variable this caller function needs to take. Back to this function definitions. In the implementation, we use the second name of each variables. So income and the rate. Okay, so let's go back to this caller function. So we simply hit enter, then it brings that all. Here, taxable income, we need to put there double. So let's say my tax is at $10,000. And tax rate is $10,000 tax rate in New York. I think that is a non-tax, right? If annual tax is at $10,000. Let's say that is 20%. Then we can put 0.2%. Okay. Bring that here. So if you see here that my tax colon, and then that is space right now. So I want to put this here. How can I put that there? Then I have a backslash, open and close parentheses. There is my tax. Then quickly it says my tax is this. $10,000, then I think $2,000, right? That is a tax. But 2000.000030, something awkward. So we can do in this case, I want to do plus, no, string. String has a format, colon, I think we need to put here, that should end there, format, and point to two floating points, and take that my text, string format. Is this or without that? Floating points. Let's see if I have similar things. String format, I think it should work like this. String. we put the percent sign. Here, percent sign. Percent sign. Okay, great. So tax is my tax is $2,000 dot 00. That is my tax is. I'll put there $2,000. Right, my tax is $2,000. And then we can say here variable income, integer, we can say $10,000. So this is income. With a double income. Okay. So my tax is $2,000 for the taxable income, $10,000. That's what I have here. You can put here 00 if you want. Okay. So in this way, we practice the how we can use this text and the images. Images we didn't do much, right? We can do images as well if you want, but